Okay, our next topic is a beam. Now, what is a beam? A beam is a structural element that primarily resists loads applied laterally across the beam's axis. So a beam and a column almost have the same shape, but it differs on the direction of the load that it's applied to it. If you can still remember from the previous topic, the load of a column is directed parallel to its axis, something like this, while a beam, the direction of the beam's load is perpendicular to its axis. Okay? So what are the different kinds of beams? You have a joist, beams, and girders. So how do you differentiate the three? A joist are used under floors and ceilings for support. So this is commonly used for a wooden construction. So I don't know if you still can see this nowadays because we rarely have wooden structures, but this is how it looks like. This one. This is a floor joist. Still, it follows the same concept with that of a beam, since the load is directed or located in its perpendicular to its axis, something like this. Okay. Now, a beam, on the other hand, a beam carries a load passed by the joist, which is this one here. So the joist passes its load towards the floor beam, and then the floor beam passes its load to the girder. So the girder is the strongest among the three, and usually this is the one that has or carries lateral loads. So when you say lateral loads, it's a kind of load that is moving this direction or this direction. That's why beams are the ones that connect your columns. For reinforced concrete structures, the beams are carried by the girders, something like this. So if this is your column, this one and this one, the beam that connects, the structure that connects the columns together are what we call as girders, because when there is load, there is a tendency for these columns to push towards the girder. So there is lateral support required. While the beams, on the other hand, this one, passes the load onto the girder. So as you can see in the reinforced concrete structure, we no longer use floor joists, but instead what we have are beams and girders. As you can see, the beams pass its load to the girder, therefore making the girder a stronger version of a beam. Now, what are the different kinds of beams? The first one that we have here is the cantilever beam. So as you can see, a cantilever beam has only one side that is supported, and it's supported by a column similar to this one. See, this is supposedly a column, but you cannot see it because it's covered. So this is the column, and it carries this beam. So only one side of the beam is supported, while the other is a free end. Next one that we have would be the continuous beam. Okay, a continuous beam is a beam that has, well, another beam right after it. So let's say, for example, this beam in here, we will consider this as continuous since there is another beam right beside it and another beam right beside it. But this other beam, though, this one, is already considered discontinuous because there is no beam right after it. Similar to this side as well. There is no other beam right after it. Okay? Again, if there is another beam after, then you consider that as a continuous beam. Okay. Next one. It would be the T-beam. So this is still based on form. These are the types of beam based on form. So from the name itself, T, it actually has a form. It forms a letter T. So in the picture given in here, it's a combination of two T-beams. So this is T-beam number 1 and T-beam number 2. See? As you can see, this whole thing is actually part of the beam itself. Unlike the shape that we usually know of, that the regular beams are shaped in a rectangular cross-section, while this one follows a letter T configuration. Okay, T-beams are commonly used for structures which require bigger loads, such as bridges, and if you've noticed, I think flyovers too. Well, it's almost similar to a bridge though. So yes, we commonly use them. We commonly use T-beams for that. Okay. Now we move to the types of beams based on material. Okay, the first type of material that we commonly see used as beams is steel. So steel is commonly used for steel structures like parking buildings. If you've noticed, UC Mandawi, UC Mandawi Medical, I don't know the name, but it's the hospital for UC. They also use this for Sacred Heart Church in Hakusalim. They also have this near SM Mobolo, no? So it's faster. From what I know, it's faster to construct, but it's a little bit more expensive than your reinforced concrete type. Another kind of material commonly used is this timber, but this is more of an architectural element rather than a structural element, because as we know, timber is vulnerable to decay, so it's not really considered as a good material for long-term use. So timber beams are considered an architectural element, although there are new kinds of materials wherein they were able to treat wood to make it last longer. I think the material that they used for the new terminal in Mactan International Airport, they actually used wooden material for the arc, no, for the arches. Okay, another type of beam is precast. Same with that of the previous topic, wherein for the columns, wherein they order this off-site. There's another maker for the precast beam member. So you actually have to order this, make the necessary measurements, and then they will bring this on site already made. So you'll just have to assemble this. So if you want to see an actual precast beam and column, you can check out the new building, or should I say extension of SM Mabolo. So while you're actually driving around the ramp going to the higher floors na parking spaces, you will see that the extension building is using precast materials. Okay, the last one would be the reinforced concrete. So reinforced concrete is a combination of it's a combination of concrete and your steel bars. Okay, so this is what we commonly see in your drawing details, structural details for your beam. So you usually have here 3 cross sections: the left support, the mid span, left support, the mid span, and the right support. Now sometimes the drawings will also have end support and mid-span. If it says end support and mid-span, it only means that your left and right support will have the same details. So for this one, it shows that the left support has 5 bars. So for example here, it has 5 bars as your top bar. And then when you reach at the mid-span, you only have 2 bars left. When you reach the right support, it goes back to having 5 bars. While your bottom bars will have 2 on the left support, and then it goes back to having 3 in the mid-span, and then 2 again at the right support. Now, what does it look like in actual? So this is an example of rebar detail in 3D. So as you can see, although this is a different rebar detail, but based on the previous slide, it has 5. That's 5, 2, and then 5 again as top bars. So it should look something like this. There's 5, 1, hold on. There's 1, 2, 3, and then 2 more at the bottom, like that. There's 5. And then at the middle, it has 2, so we'll just continue the 2. And then once you reach the other end, it has 5 again. Okay. Now if you look at the bottom bars, you have 2 and then 3 in the middle, like that. And then another, it goes back to having 2. Now, what's the point or purpose of having this configuration? So if you've already taken, I think, mechanics, you will notice that in your mechanics, you will learn that beams, when they are loaded, they will bend like this. So this is just an exaggeration of how the deflection will look like. So the red is the original position of the beam. So once you put load on it, it will bend something like this. Okay, so the bend will go something like this. Now this part, sorry, so since it bends like this, you'll know that this part, will be in tension, and then tension, while this part will be in compression. This one also will be in compression. So remember, the purpose of having rebars is to control tensile stresses, or refrain or reduce the stresses caused by tension. So what we do is we add more rebars in these areas here and here, and then you limit the rebars here or lessen the rebars in here in areas where there is compression, because the compression will already be carried by your concrete. Same with the bottom bars. This one, the area where there is tension, that's where we provide more rebars, and then lessen your rebars in these areas. You lessen. So in the drawing here, this area here, the support end, or the left or the right support, and also the middle part of the bottom bars will be the ones requiring more rebars, while the one in the middle will require less rebars, because again this will be in compression, this part, while this one will be in tension. So I hope you understand why the arrangement of rebars is way different than that of the column. Although they also have ties that hold them together. So this one, these are the ties. No, take note, these are the ones that we consider as stirrups. So stirrups are only for beams, so you have to take note of that. Beams, while lateral ties are for columns. So please, when you have your outputs checked in the laboratory, please do not ask me, "Ma'am, can you check our stirrups?" No, we haven't had, we're not done with the beams yet. Naapat na sa columns. So we use the term lateral ties. So I hope you take note of that. So this is how it looks like, although we cannot really see the other end. But like what I've said a while ago, there's more rebars at the support for top bars. So support, top bars are more on, there are more top bars on the support, while in the bottom bars there's more in the midspan. Call this end support. More rebars. There's more rebars at the end support for top bars, and there's more rebars at the midspan for bottom bars. So please take note of that. Okay, so I think that's the last slide for my beams. Okay, so since we still have time, I will continue discussing the continuation of construction methods. So I think the last part that I discussed was about concrete pouring. So Once you're done with the concrete pouring, you do the vibration to make sure that there'll be no more voids, and to make sure that your concrete is evenly distributed all throughout the formworks. Okay. So one material that you would commonly see in the construction of reinforced concrete material is what we call as a formwork. Now the formwork uses what we call as phenolic board, although this is not the only material that we used for formworks, but this is one of the more sturdy material as a formwork because of the surface. As you can see, it's been treated. It's so shiny, it's been treated. It lessens the tendency to absorb liquid or the water coming from your wet concrete. Okay, so you can actually reuse this more times than you can actually reuse ordinary plyboards. So the purpose of a phenolic board is, of course, to lessen the cost, although I think this is more expensive than your regular plywood. But the good thing with this, though, is although it can still be, it can still, what do you call this, decay or be damaged from continuous use, but it can be recycled more often than that of your regular plyboards. The next item that you will see is the concrete spacer. I think I've discussed this already, from the previous topic, wherein I mentioned that this will make sure that your concrete, your rebars will have the correct thickness of concrete cover. Okay. Now another term that we commonly use in construction site is the term splicing. Now your rebars might not be enough, it might not be long enough. So what you do is you add another length of rebars. So in order for you to do that is you use splicing in here. Now from what I know, you do not actually splice like a series of rebars in the same spot, because this would mean that this area here is actually a weak point. What they usually recommend is you splice at different points. So if this is where you're cut off, this bar, so let's say for example these are vertical bars, the next splicing should occur somewhere lower than this or higher than this, as long as they don't fall on the same spot. Because again, if you follow this kind of arrangement, this would mean that this part is actually a weak link for the entire cross section. Another thing that we commonly see is the formworks. So for the columns, you have different configurations. in here you have two different kinds of formworks, although there are so many configurations of formworks. This one, the first one on the left, is actually using a combination of, I would assume that the brown one there is a phenolic board, and these are channels. Now, the yellow materials are channels, which makes sure that the formwork doesn't buckle once you pour in the concrete. This is very important, especially for columns with this size of cross-section. No? So together with vertical studs, the yellow vertical studs are using channels. There are braces, the red ones here, this one, the braces. The braces will hug the vertical studs together to make sure that your studs will be set in place, no, and it will no longer move. This one also, this equipment here, this one, are your braces to make sure that it is vertical. No, vertical, remember the plumb bob that I mentioned. This is to make sure that it doesn't sway to the other side. So it should be provided on X and Y axis to make sure that it is indeed vertical. Okay, now for our laboratory, we will not be recreating this one because it's more difficult to recreate. So instead, we'll go with the wooden or the timber formworks, which is this one, the one on the right. Okay, so what you will need to do is to make 4 sides of vertical and horizontal studs placed on a plywood. So if you look at the side, the studs will look like this. These are the vertical studs, this one, while there will be horizontal studs provided also. So the spacing for the studs would be around 40 or 0.4 meters apart to make sure that this and this will not bulge once you pour in the concrete. Because if the spacing of the horizontal studs will be too much or too big, then therefore this will be considered as a weak spot. Therefore the concrete will, or the column will look like this, no? So the spots where there are no studs. Okay, so from the top view, the studs will be, or the formworks will look like this. Let me try to draw. So it will look like this. So this, oh, hold on. Oh no. Hold on, let me try. Okay. Will look something like this. So if this is the size of your column. So you'll have to provide a plywood here. This will be the plywood, and this will be another plywood. And then you will provide a vertical stud here and also another vertical stud here. Hold on, I need to redo this. So if this is your column, so this will be your plywood. That would be your plywood, and there's also another plywood here to be your formworks. And then to support that, you have your vertical stud here and another vertical stud here, vertical stud here, and then here, vertical stud, vertical stud. And then these are the vertical studs. Now the purpose of us arranging it like this is to make sure that when you do the if you assemble the formworks, you can actually nail this here, nail it here, nail it here, and nail it here, that way. And then to make sure that your formworks doesn't bulge, you add your horizontal studs. So I hope you can understand this. We're looking at it from the top. So this is your top view. These are your horizontal studs. So if you can remember, this is your horizontal stud, this is your vertical stud. So there it is, your plywood. Okay, so I hope you understand how that's being done. And then again, once you have made your formworks, you pour in the concrete again and then do a vibration, same as before. But for small scale construction, you actually use this guy is using just a regular rebar to tamper onto the column in here to make sure, because for small scale construction you actually do not make use of expensive equipment such as a vibrator, so you can do tampering on it. So although you cannot you only have to tamper it enough to make sure that there are no voids, and because if you tamper it too much, there's a tendency for the water to bleed out of the concrete, no? So, and you know that when it bleeds out, it will go, you will see some honeycombing, no, or something like this. So you can see after stripping off, you call it stripping off. Once you remove the formworks, it's already stripping off. This here is what we call as honeycombing. I think I have discussed this previously. So honeycombing is caused by a lot of things. It could be from a lack of water, or too much water, or less tampering, or could be so much tampering, or it could be a lot of things. No, there are so many things that affects or influences your workability, no, workability of your concrete. Okay, I think that's enough for today. Maybe next meeting I will discuss about slabs. Thank you.